To determine the minimum allowable size of the ungrounded conductors for the first calculation, we need to refer to the National Electrical Code, specifically Table 310.15. B16. This table provides ampacity ratings for conductors based on their insulation type, temperature rating, and installation method. In this case, we are using type THHN copper conductors and conduit with 75 degrees Celsius terminations and a 200 amp service. According to NEC Table 310.15. B16. The minimum size for 75 degrees Celsius THHN copper conductors and conduit for 200 amp service is American wire gauge number 4. Therefore, the minimum allowable size of the ungrounded conductors is American wire gauge number 4. Now let's move on to the second calculation, which involves determining the minimum allowable size of the branch circuit conductors for a 240-volt single-phase branch circuit supplying an electric furnace. The furnace has elements rated at 12 kV and a motor rated at 1.5 kV. The equipment terminations are rated for 75 degrees Celsius and type THW copper conductors are to be used. To solve this, we need to reference NEC Article 210.19 and Table 310.15. B16. Firstly, we need to determine the total load. The elements are rated at 12 kV, which is equal to 12,000 volt amps. The motor is rated at 1.5 kV, which is equal to 1500 volt amps. The total load is the sum of these two, which is 12,000 volt amps plus 1500 volt amps, equaling 13,500 volt amps. Secondly, we calculate the circuit current. The circuit current is equal to the total load divided by the voltage. In this case, the total load is 13,500 volt amps and the voltage is 240 volts. Therefore, the circuit current is 13,500 volt amps divided by 240 volts, which equals 56.25 amps. Thirdly, we determine the minimum conductor size. From Table 310.15. B16. For 75 degrees Celsius THW copper conductors and conduit, the minimum size for a 56.25 amp circuit is American wire gauge number 10. Therefore, the minimum allowable size of the branch circuit conductors is American wire gauge number 10. In summary, for the first calculation, the minimum allowable size of the ungrounded conductors for a 200 amp service using 75 degrees Celsius THHN copper conductors and conduit is American wire gauge number 4. For the second calculation, the minimum allowable size of the branch circuit conductors for a 240 volt single-phase branch circuit supplying an electric furnace with a total load of 13,500 volt amps using 75 degrees Celsius THW copper conductors and conduit is American wire gauge number 10. These calculations are crucial for ensuring the safety and proper functioning of electrical systems. Always consult the latest edition of the NEC and local electrical codes for specific requirements in your area. Remember to consider factors such as ambient temperature, number of conductors in a raceway, and voltage drop when selecting conductor sizes. Using the appropriate conductor size prevents overheating, reduces the risk of fire, and ensures efficient power distribution. It's always best to consult with a qualified electrician or electrical engineer if you have any doubts or complex electrical design requirements. They can provide expert guidance and ensure that your electrical systems meet all applicable safety standards and regulations. Additionally, proper installation techniques are essential for maintaining the integrity of the electrical system. Ensure that all connections are made properly and that conductors are protected from physical damage. Regular inspections and maintenance can help identify potential issues early on and prevent costly repairs or hazardous situations. By following these guidelines and adhering to the NEC, you can create a safe and reliable electrical system for your home or business. Remember that electricity can be dangerous, so always take precautions and prioritize safety when working with electrical systems. If you're not comfortable performing electrical work yourself, it's always best to hire a licensed electrician to do the job. They have the knowledge, skills, and experience to handle electrical tasks safely and effectively. In addition to conductor sizing, it's also important to consider other aspects of electrical system design, such as overcurrent protection, grounding, and bonding. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overload and short-circuit conditions. Grounding and bonding help to minimize the risk of electric shock and ensure that electrical equipment operates safely. A well-designed and properly installed electrical system is essential for the safe and reliable operation of any building. It's important to pay attention to detail and follow all applicable codes and regulations to ensure that the system meets the needs of the occupants and protects them from electrical hazards. Whether you're building a new home, renovating an existing building, or simply making electrical repairs, it's important to prioritize safety and quality. By working with qualified professionals and following best practices, you can create an electrical system that is both safe and efficient.